Hello, my name is Paul Fitarau, and in the following minutes I'll give a demo on DTLS-Fuzzer. DTLS-Fuzzer is a protocol state fuzzer that can be used to test DTLS client and server implementations. The fuzzer is open source, with the source code available online. The fuzzer has shown to be effective. Recent work used DTLS-Fuzzer to find various bugs in well-known libraries, which led to fixes in 5 of these libraries. Now, what does the fuzzer actually do? As a protocol state fuzzer, DTLS-Fuzzer implements a mole learning algorithm by which it exchanges inputs and outputs with the black box system and eventually generates a state machine, capturing the input-output behavior of the system. The state machine can then be inspected to find bugs in the target system. So far, we've talked about how DTLS-Fuzzer works. But how can you use DTLS-Fuzzer? Well, to use DTLS-Fuzzer, we must first, of course, download its sources. Once we've downloaded the sources, we then have to deploy DTLS-Fuzzer. And this can be done by running from within DTLS-Fuzzer's parent directory the prepare script. We can verify that DTLS-Fuzzer has been deployed successfully by the presence of the target folder. In this target folder, we should find the DTLS-Fuzzer jar. The next step is to set up the system that we want to test. To do that, we can use the setup-SUT script. The setup-SUT script supports automatic deployment of a number of implementations. Now, suppose we want to test a recent version of embed-TLS. We would just supply that version to the setup-SUT script, and the setup-SUT script would automatically deploy that version for us. So we've deployed the system on the test and DTLS-Fuzzer. Well, the next step is to use DTLS-Fuzzer to generate a mole for the target system. And to do that, we execute DTLS-Fuzzer's jar and supply it with the right arguments. Now, the list of arguments can be long, which is why we compiled a set of so-called argument files. An argument file contains a list of arguments for a common mole learning configuration. We've compiled argument files for all major libraries, including embed-TLS. Suppose we want to generate a mole for an embed-TLS client with an alphabet which uses pre-shared keys and with random walk as our test algorithm. Then we would supply the argument file whose name matches the experiment description. I will, in addition, set a time limit to mole learning of 3 minutes. You might think 3 minutes is insufficient, but actually 3 minutes is enough for the mole learner to generate an accurate mole for this particular configuration. Okay, the experiment has finished. Let's check the results. To do that, we'll check the results folder. And in the results folder for the experiment, what we can find is the input alphabet that was used in learning, the argument file that was used, the hypotheses that were generated during the mole learning procedure, and what we're most interested in, the learn mole. And with the learn mole of the embed-TLS client, we can move to the last step, which is analyzing this mole for bugs. Now, to analyze the mole for bugs, we need to visualize the mole. And to do that, we could think of just running xdot directly on the learn mole. However, the problem is that the learn mole is quite big. It has many edges. For that reason, we will instead use the tree-mole script, which will first prune the mole, removing some of the edges, and only then supply it to xdot for visualization. Notice our trim script was able to prune 50% almost of the edges of the mole. So this is the prune mole. Let's analyze it for bugs. One of the things our script did, besides the pruning, is that it colored paths on the mole. A colored path corresponds to an expected handshake. A heuristic one can use to find bugs is to analyze paths other than the expected handshakes that connect state 0, the initial state, to state 7, the handshake completed state. On occasions, such paths may expose vulnerabilities in the system. Of course, such a heuristic will by no means find all the bugs in the mole. In fact, the process of manual inspection is prone to miss bugs, is time-consuming, and requires protocol knowledge. For these reasons, in our next release of DTLS-Fuzzer, we plan to make bug detection fully automatic. So stay tuned, and thanks for your attention.